So what we're looking at in this video is how to factor polynomials. So we've worked on factoring quadratics. So we're going to use some of those skills in order to factor some polynomials. So there's a couple new things. We're going to take some time and work on these a lot because that is super important. So let's jump right in. So you guys can look over the little list there above. So example 1. So we're looking at this. So remember, the first thing we're trying to do anytime we're factoring is to look for a greatest common factor. So if we see in example 1, we have an x in every single term. So what we're going to do is we're going to take that x out and write what's left. So we have an x squared minus 4x minus 5. And from here, it's a quadratic, so we can factor that. So we have that. So factors of -5 that add up to -4 would be -5 and 1. Okay, so they can be as easy as that. We're taking greatest common factor out, and it turns into a quadratic. This next one, we have a 3 we can take out and a y cubed that we can take out. So 3y cubed is going to be the greatest common factor. And what's left is a y squared minus 16. We know that's a difference of 2 squares. Or we can think factors of -16 that add up to 0. We get a y plus 4 and a y minus 4. C, we can take out a 5 out of all 3. We can also take out a z squared. So 5z squared is the greatest common denominator, or greatest common factor. So we're left with z squared plus 6z and plus 9. So now we have factors of 9 that add up to 6, so 3 and 3. So we have z plus 3. We know it's z plus 3 times z plus 3, so I'm just going to write it as a quantity squared, just to save some time. And that should be it. So that's it for things that we kind of know already. So looking at some of the special polynomial rules, we already know the difference of 2 squares. Now we need to know the sum of 2 cubes and the difference of 2 cubes. So these are the formulas. A cubed plus b cubed equals that. So we kind of dealt with this a little bit, where we took a and b and plugged them into an equation for the binomial expansion. So we're doing the same thing here. We're just plugging in values of a and b. So we need to find the cube root of these numbers that show up. So we'll look at that in the example. So example 2, we have x cubed minus 125. So we can recognize that x cubed is a perfect cube and 125 is a perfect cube. So we know that our a value is x and our b value is 5. So 5 cubed is 125. So we go ahead and plug them into the formula. So we're dealing with a subtraction of 2 cubes. So we're over here. So a minus b, so x minus 5 times x squared plus ab plus b squared. So x squared plus 5 times x plus 5 squared. And that's it. Because we can't factor this quadratic any further, so we just leave it. Alright, so this next one, we would have to do some greatest common factor first. So we can take out I think at most a 2 and an x squared. So 2x squared is greatest common factor. So we're left with 8x cubed plus 27. So 8x cubed, if we take the cube root of that, it'd be 2x. And then the cube root of 27 is 3. So we can go ahead and use our formula. So greatest common factor on the outside, and then we're dealing with an addition, so a sum. This is the equation we're going to use. So a plus b, so 2x plus 3 times a squared, which would be 4x squared, minus a times b, so 2x times 3, that'd be 6x, and then plus b squared, so 3 squared would be 9, and we have our equation. Okay, so moving on. So example 3, we have 4 terms. So up in the directions it says if you have 4 terms, try to factor by grouping. So this is a skill you should have learned in Algebra 1. If not, I'll walk through it. So we take our first 2 terms and we look for a greatest common factor, which is x squared. So we're dividing out an x squared, so we're left with an x plus 3. And we do the same thing with the second 2 terms. So we can take out a negative 4. So we pull out a negative 4 to the front. And we get x plus 3 left. And the goal here is to have these binomials be the same. So they're x plus 3 on both of them, so we're good. So now what we do is we write that binomial, whatever's remaining inside of both of those after the greatest common factor. And then we take what we factored out and it creates its own binomial. So the x squared from here and the minus 4 from here. And now we try to factor even further. So x squared minus 4 we know is x minus 2 times x plus 2 and the x plus 3 will come down and we are all factored. Next one. So we have 3 terms. It's a 4th power polynomial, but we can treat it just kind of like a quadratic because the middle term is half of the first term power-wise. So x to the 4th, x to x squared. So what we're going to do is we're going to treat it like a quadratic thinking-wise because we know that x squared times x squared is x to the 4th. And now we're just thinking of factors of negative 27 that add to negative 6. So we have negative 9 and a positive 3. And we try to factor each one of these. So we cannot factor the x squared plus 3, but we can factor the x squared minus 9. So x minus 3, x plus 3, and then x squared plus 3 drops down. And we're all factored. Alright, last one. So we can take out a 3x squared out of all of these. So 3x squared is greatest common factor. So first one would be an x to the 6th. Next one is a 5x squared, or sorry, 5x cubed. And the last one is plus 6. So same thing, we have x to the 6th with 3 terms, and the middle term is an x to the 3rd, which is half of that. So we can go ahead and do x to the 3rd times x to the 3rd. And now all we have to do is factors of 6 that add up to 5. So 2 and 3. And we check to see if these can be factored. So perfect square, or perfect cube. 2 is not a perfect cube, and 3 is not a perfect cube. So this is our final answer. Alright, so let's look a little deeper into something we talked about before. So factor theorem, I know if I divide a polynomial by some other polynomial and we end up with a 0 remainder, we've said that that would prove that it is a factor of the polynomial. So we're going to use that and we're going to continue on after that. So if x minus 3 is a factor of this function, what is another factor? So what we're doing is we're dividing to see if we can figure out what the other factors are. So we're still dividing out. So you could do long division, you could do synthetic division, whatever you choose. I'm going to just do synthetic just to speed it up a little bit. So I know that that would turn into a 3. We have 7, negative 23, and 6 for our coefficients. 7 times 3 is 21. Add them up, we get negative 2 times 3 would be negative 6, so 0. So we know if we write this as a polynomial, we're dropping down 1 power because we divided by a linear. So that would be 7x minus 2. And whenever we get an answer, we look to see if we can factor it further to see if there's more than one factor. But this cannot be factored, so 7x minus 2 would be the other factor of that function. Let's do this one, because this is going to be a little bit different here. So negative 4, we have a 1, a 5, negative 2, and a negative 24. One drops down, we have negative 4 there, 1, negative 4, negative 6, and 24. So we do get a 0 remainder. So it means it's a function, it's a factor of that polynomial. So x squared plus x minus 6. So we get that polynomial from our division. And now we see if we can factor this, which we can. So factors of negative 6 that add up to 1. So it should be a positive 3 and a negative 2. So those would be the two other factors of that polynomial. Okay, so go ahead and try that checkpoint there. Alright, so we should have either did long division or synthetic division. So listing out our coefficients. So cubed would drop down 1 power to a square, so x squared minus 2x minus 3. look to factor. We got factors of -3 that add up to -2. So -3 and 1. So there should be your two answers. Alright, last problem. So the volume of a rectangular prism is given by this function v of x. Find the missing measures. So all we're doing in here is what we did in the last couple of examples. We're taking a polynomial. They have one side given to us. We need two other sides. So we're just going to divide v of x by our known side to find the other two sides. So 4, there's a 1, a 3, -36, and 32. So 4 drops down. 4 times 4. Oh, not a 4. 1 drops down. 4 times 1. I was thinking ahead. 3 plus 4 is 7. 4 times 7, 28. -28, and again -32. So 0. So our function would be x squared plus 7x minus 8, which would factor down into factors of -8 that add to 7. We have 8 and -1. So those would be the two other side lengths, the missing side lengths, those two. Alright, so that's it on factoring polynomials. So we're going to work on these quite a bit because it is super important. So let me know if you have any questions and I'll get back to you.